formally welcome you all again in City University and especially in School of Engineering and Technology. I am Dr. Inderjeet and I am handling Research and Innovation Center for Excellence. Okay, so this is a specialized center for students where you can come with your innovative ideas. Okay, if you have anything in your brains and your ideas and you want to convert it into reality, you want to see it into reality, okay, so you can contact us and you are here, we support you in converting your ideas into reality, okay. So we welcome students from all the branches, not only specialized for mechanical, but computer students, especially they are software oriented, but if you want your application in some hardware part, so we are here, we have a center. So where you can bring your ideas, you can make applications, you can use sensors, practically hardware-based projects. You can come and do it in here. Okay. And today in this session, I will show you some projects that we have developed, all developed by the students. So you know, most of the machines, the parts, they are imported from China, right? So we are specialized in. We are fabricating machines here in-house. Okay, we are developing 3D printers, CNC machines, laser machines, so we are doing it here, some small scale robots. Okay, so in the next 20 or 30 minutes, I will show you what we have done. They have made a team and they have like brought their ideas to us and then we have converted the same thing into a real life project or product, right? Okay, I hope it is visible to everyone. These are some glimpses of RISE. RISE stands for Research and Innovation Center for Excellence. Okay, and we have some specialized domains. Like we are working in rapid prototyping. Okay, rapid prototyping lab. We have a specialized lab for rapid prototyping. Okay, we are not doing 3D printing. It's also called 3D printing. Okay, we have a lab where we are fabricating 3D printing machines also. Okay, and like you can see in the front we have a machine working live. Okay. So the live 3D printing is going on. Okay, in the session I cannot cover each and everything, but it's basically in one or two lines. If I say, if you have anything in your mind, okay, you want to develop a remote, you want to develop a bottle, you want to develop any object, any machine part, okay, you can just design it in your computer. That's called 3D modeling or 3D designing. Okay, that is again one of the domain that you can learn in RISE Lab. Okay, so you can learn 3D designing. So where you can convert your design. You know, earlier we do sketching. Okay, we used to draw sketches. Our imagination was drawn on the paper in the form of a sketch. We also did some clay modeling. If anybody have done, we want to make something, we did clay modeling. So nowadays, you know, all the things they are developed using computers. We do 3D modeling in the software, right? And then to convert your software-based design in a real-life product, okay, you can do 3D printing, right? 3D printing is converting your, you know, software file into a real-life product that you can feel in your hand. You can see the dimensions, you can feel, you can see the shape and size. You can redesign, you can modify, and you can, you know, print it again. Okay. If it is visible, the live 3D printing is also going on. In the next 30 minutes, I will generate a small part. Okay, that's a small machine part in a computer, and that is you know, fabricated within 30 minutes, and you can use that part in your machine or in as any component, right? So we specialize in rapid prototyping. Okay, rapid prototyping or 3D printing. So second, we have some CAD designing. We train students in CAD software. CAD stands for computer aided design. Okay, if you want to design something, it can be for games, not only for mechanical purpose. You can also design for gaming purpose, right? So you can see some vehicles, buildings, lot of things they are designed in CAD software, right? So if you want to learn CAD, we also provide services in CAD. Okay, if you want to learn, you know, artificial intelligence, there are some domains for computer science they are also implemented in CAD software for mechanical purpose also, right? So I cannot elaborate it more, but your computer application, the application of coding and AI machine learning, that is again very important in CAD software. If you want to learn CAD, right, it's I will suggest for all the engineering students to learn basic CAD, because always we want to create something not only on the software, but if you want to see it in physically or in the realistic form, so you can create your own models. Okay, it's not only for mechanical. You can create fascinating objects, your bases and any models, anything you want, you can imagine, and you can create using a CAD software. Okay, so we are specialized in these two domains. So this is the lab, rapid prototyping lab. We have 3D printers. We have in-house 3D printers also that we are developing from scratch, from zero. We are fabricating these machines. Okay, and so we are fabricating machines here. We are not only just printing, not only rapid prototyping, but we are empowering our Indian students to develop these machines in India only, here in Punjab. Instead of importing everything from China, so we are developing these machines here. So you can see the another machine here, that is laser CNC laser. Okay, I'll show you the PPT if it is not visible. So this is the student chapter. We call it a student chapter because we have a team from all the domains. So we have from CSC, electrical, mechanical, all the students, they combine together, they make some projects, they participate in competitions, right? So these are some glimpses where students were working in Bangalore, right? We participated in National Solar Vehicle Challenge, okay, in 2018, right? And we won 50,000 cash prize also for the best design and best startup pitch award. Okay. Why we call student chapter? Because we motivate all of you not only to study here, but do something innovative, not only in your single domain, but to be multidisciplinary, right? So you should involve yourself in some projects, okay, that will help you in your career, in your placements, and a lot of things. So this is the first project or a product developed by a student from BCA. I will highlight the branch because it's not only for mechanical. Your BCA student, he was involved in designing this thing in CAD, right? Then he was also doing coding part. He developed an app. Just within few minutes, I will run this project live in here, okay, using an app developed by the student. Okay, so I'm motivating you to see the application where you can apply your coding, where you can apply your programming in different domains, right? He was involved in electronics part of everything, okay, doing the coding, manufacturing it, fabricating this thing here. Good place, sir. Right, this is a 6 degrees of freedom robotic arm. Okay, it can be operated using a mobile phone app. So I will stop here and just run this thing for 1 or 2 minutes. It's a phone. So I have an app here. Okay, I hope you can see the app. It is developed by the student. Just look like a gaming console. Okay, so this is the interface developed by the student based upon his creation, fabrication. Okay, and I am controlling this with the help of wireless connection, Bluetooth connection. Okay, so I can operate this machine. So this is a combination of mechanical, electrical, sensors, programming, coding, application development. Lot of things are developed in this small project. Okay, so I will just run this thing, and again I'm motivating especially CSE students. This will open up your brain in different domains. Okay, so how he applied not only in the programming, not only app development, but he applied entire thing into a single domain. hope those students who can see this thing. Okay, this is a 6 degrees of freedom, a robotic arm, very small prototype. Industries use robotic arms that I hope everyone will know that industry will use robots in future for different applications, for pick and place, for deliveries, for manufacturing, for welding, for assemblies, lot of applications. Right? So he has made a small prototype and it's a vehicular motion, so it can move also. It has motion like your arm. Your arm can move in different directions, not only in X, Y and Z. I hope everyone knows what is X, Y and Z. Right? Everyone knows what is X, Y and Z. That is some axis. Axis like this, Y goes like this, and third axis is Z. So this can move in 5 or 6 axes. Like your arm cannot move in X, or you cannot go in, you do not go like this. You can simply move your arm in different axes. So this like robotic arm, it also moves like this. It has 6 motors that are operated in different axes, and also includes a vehicular motion. So I hope you haven't seen any vehicle moving around like this on its own axis. So it can move, specialized vehicle, it can also move on its own, like, and moving right side, left side also. We have to take a turn to move a vehicle. Yes, it can move 360s, orbital motion. Okay. And again, I'm showing you the app developed by the student. Okay, just to motivate you to be hardware oriented also. Apply your learning in real life applications, right? Also, so he was your senior Param from BCA, and again I will highlight what is the benefit in your career. He was placed before his like degree completion. He was placed in 5th semester only. He had 6 semesters and he was placed in 5th semester only due to these projects. Okay. Next is our in-house developed 3D printer. Okay. 3D printer, again we have developed it from scratch. Students, a team of students, they have developed 3D printer from scratch. We have added lot of features, IoT features. It can be operated wirelessly from home, and many improved features we have done it here. Next is CNC laser machine. CNC is again computer numerical control. We are controlling a machine with the help of computer code with a program. So machine will move in X, Y or Z axis as per one instructions given in the program. Okay, so this is a CNC laser machine. So this can do cutting and engraving. I hope you have seen some laser manufacturing, laser engraving or some kind of operation. So this again, this is the machine here, and this is our in-house developed machine. Again, it involves designing how the machine will look, designing of parts. Okay, and here we have some orange color parts that are designed in the computer and they were fabricated using our 3D printer. So we are not purchasing anything from outside. So we are developing, we are designing and fabricating also each and everything in-house, right? From China or there are a lot of, I hope you know, due to COVID there were issues in importing from China. Okay, so and it was costing more than 50 or 70,000. So we have developed this a very small scale, low cost machine that is costing only 15,000, hardly 15,000. Okay, so importing anything from outside, we have capabilities to manufacturing everything here. So we are motivating students to do fabricating their own machines in rice, specialized in rice. And those who are interested in automobile, okay, some boys they have they like automobiles, driving something. So we are fabricating. Again, this was a go-kart manufactured by a team of students. It was designed and fabricated here. Again, lot of things were involved. Cutting, fabricating, each and everything was involved. Okay, using an engine. So this was a go-kart that we prepared for a participation in an event, but unfortunately due to COVID, it was not held. Right? But this is a go-kart you can see we have in the Rice Lab, and in few days you will see the working in the campus. Right? Again, this is another CNC machine for wood cutting. So we are again manufacturing, this thing is ongoing, we are manufacturing, fabricating this machine for wood cutting purpose, wood and aluminium. Okay. So we are fabricating machines. I am highlighting this part. We are not bringing anything from outside. Instead, we are fabricating these machines here, so that in few years we can offer some products. Right? These products right now, these are prototypes, but in upcoming few years we are proposing this to be a proper product, so that we can sell it in India. Okay. We want to be manufacturers, we want to be entrepreneurs. So we are fabricating these machines here. So this is a electric vehicle, solar electric vehicle we fabricated by a team of 18 students, and 14 of them were from CSC, computer science, right? So in 2019 we participated. We took this vehicle to Bangalore in a train. We disassembled this entire vehicle. We took it to Bangalore and we participated. We assembled it again there. We participated in some events, some challenges, and we won Best Startup Pitch Award, Startup Vehicle Award of 50,000 prize. And for overall design, we won 6th position Pan India, right? So that we motivate you to bring and be a team, so that you come with a product, and you can participate in contests all over India. Right. So again, summarizing some projects that we have done, we have completed till now, and these are some our projects in pipeline that we are currently developing or planning for some future. In next 3 or 6 months, we are planning to make a drone. It's already in progress. So the drone is currently in. It's not flying properly, but it's already being developed, right? CNC, again another CNC wire cutting machine, an EcoBot that is already developed. Filament extruder to reduce waste, plastic waste. We are making a filament extruder machine. Okay, the material used in 3D printing that we are planning to manufacture that filament. That is called filament. We are planning to manufacture that filament from waste plastic. Okay, so we are making a specialized machine. So currently you can see the CAD model. The CAD model is shown in this figure. And electric bike. So these are some projects in pipeline that we want to make in near future. And how we execute these projects, how you all students can come with your ideas. So this is we have made a small like workflow. How you can you have to bring with your ideas. Okay, we will screen your ideas if it is feasible or not, if it is scalable, if it is viable or not in our lab, right? Then we do documentation, we do designing part. Okay, first we we not start straight to the manufacturing. We do designing, we do CAD modeling, we fabricate, we redesign everything, and then we go to prototyping. Okay, we do prototyping and testing of that machine, and we then in future we want to launch it as a product. Right? So you can register here. You have facility to register yourself, register your product as a company, as a startup. You can register yourself. Okay, 2 of the students, they have registered the products in the form of a company as a startup. Okay, so university will provide you facility to register yourself as an entrepreneur, as a startup, and they will offer you each and everything, right? And especially you can come in media. It's very important nowadays. increasing your visibility outside the campus also, okay, in your relatives, to some companies. The student standing there, he was a part of 3D printing team, right? And again, he was a student of BTech, consisting of 8 semesters that I hope you know, and he was placed in 6 semester only, right? I'm highlighting this again for your career. If you are involved in these innovative products, it will help you in career. If you want to be an entrepreneur, you can move in that direction. If you want a placement, it will help you in placements also. Okay. One of the students, BCA student, was placed in 5th semester and BTech student in 6th semester. So they got a good offer just based on these their skills, right? So that is all from my side. I will motivate you all to bring your ideas, involve yourself in innovative ideas. Okay, bring your ideas. I will help you, and we are here to support you. We have facilities. We have tools available. We have raw materials. We have sensors. We have each and everything that can be used in your projects. Right? That's all. Thank you. Thank you.
Thank you, Inderjeet sir, for enlightening us about the various projects that our students can perform in your lab. So, students, even you are from any domain, okay?
You can you can fabricate anything within 20 or 30 minutes, or maybe within few hours, instead of going anything outside. You don't have to go outside. You want to make some machine, you can fabricate the parts right on your 3D printers. Okay, just to show you the small part that I printed in 20 or 30 minutes.